Alrighty, hello. Can everyone hear and see my screen all right? Perfect. All right, well, thank you so much for being here. My name is Jordan Noe. I am a doctoral student in the Nuclear Engineering Department, and I've been working on an extended reality training for a high radiation area protocol. So, what does that look like? Why do we want to do extended reality for health physics? Well, health physics is the overall study of radiation protection. So, how can we better protect ourselves when we're using radiation or radioactive materials? And the beauty about XR for these training purposes is that we don't necessarily need to be around these materials. We can follow what's called a LARA, as low as reasonably achievable. As long as we can limit our exposure to radiation, we're doing what we need to do. So, extended reality allows us to follow this protocol very well and still accomplish the same goals. It makes certification and assessment very easy to do. Remote teaching is possible. You can just have students log on to this experience and accomplish it whenever. It saves times once it's deployed. The actual facility is a very small and cramped room where only a few people can be there at a time. So this is nice because it gives students a chance to train at their own pace and not be so crammed on time. Um, and it gives it's reusable, it's very revision simple, and it is incrementally upgradable. So it provides a lot of unique aspects to this, and it can be used to simulate unique puzzles or horrible scenarios. It's not necessarily intended as a replacement for in-person training, but it better prepares the student to know what they are to expect. So, how do we want to do this scenario? Well, we want to teach students how to safely navigate a highly regulated radioactive source. You can see here that this is our irradiator, and it's about a 6 curie irradiator. To put that in perspective, students typically work with microcuries that is loosely regulated, and so this is or many orders of magnitude larger than that, and so it's much more regulated, and there's more protocol that follow with that. This will be incorporated into a graduate level laboratory once it's prepared. We've designed this using Uptail, and it teaches students how to navigate different scenarios that they may or may not have seen before. So we can use this to test different learning objectives and to accomplish certain things that we want to accomplish with this. And so, how exactly do we want to do this and approach this? Because there's a lot of content that we can cover using this XR interaction, but we want to be able to hit certain objectives in certain scenarios without overwhelming the student with one specific scenario. So we've divided this up into 3 different scenarios. We have scenario 1, which is user familiarity. It just uh, very basic. It guides the user through the process, and how exactly do you do this. So a lot of students might not have seen extended reality before, so it gives the students a chance to get familiar with that and familiar with the overall process. Then we do a scenario 2 where we do another run through this, but we really make sure that students understand the processes that are going on. And I'll elaborate more on that when I get to that slide. And then scenario 3 will actually introduce situational scenarios such as what happens if the source fails? Who do you call, or what if this alarm goes off? Or what do you do in that regard? So this is just a sequence of events that we take through these scenarios so that students can better learn and understand the strategies for handling radioactive sources as a radiation protection scientist. So scenario 1. So the objectives of scenario 1 is we really want students to get familiar with extended reality. Chances are a lot of them have not seen this before, so it gives them a chance to safely navigate through the tags and not feel so rushed on time. We want them to understand the source process. So we have students follow a very specific scenario where they use the source, they follow different steps, and we just want students to be familiar with those steps so that they can do them on their own without being prompted. And this is in the form of a checklist. So we have a checklist that students need to complete to ensure that they follow specific items. And so we have students follow a checklist, and so they can be familiar with all of the protocol that need to be followed. And this is commonly seen at like a nuclear power plant. People have very specific protocol that they need to follow, and if they miss an item, it could lead to further consequences. So our main uptail design strategies for this was we wanted to use info and text tags to guide the user. We also want to use marker tags so that the user can complete certain tasks without having the form of a question tag. And we want to establish the flow for future scenarios. So this first scenario will kind of establish the flow of how the experience will go, and then we can expand upon that to further our objectives. So just an example on elaborating on the marker tags, we have this form that we have that whoever is going to use the source, they fill out, and they have to fill out certain information, such as a key checkout date, or they sign their name indicating that they have the keys to unlock the radioactive source. And so the nice thing about this is that students can click as if they were signing their own name or checking out the key number, and we can tell them in the description, this is exactly what you fill out. Since it's a little bit difficult for them to actually sign their own name, this is a method that we can do to combat that. And this is the checklist that typically students have to follow. So they need to go through each of these items and ensure that they complete them before they move on to the next step. And it's at about this step down, at about like the fifth from the bottom is where you actually use the source and perform your experiments, where it says repeat irradiation process as many times as needed. So there's a lot of things to do beforehand, and we want to make sure students are following that accordingly. To better help establish the process flow as well, we've also rendered various 3D objects. So we can render a survey meter. Students need to be equipped with a survey meter to monitor radiation. So we can put this as a 3D object and have that set to a marker tag so that we can essentially record a 2D video that shows this is what the survey meter is reading. If it reads too high, then we can do another branch of tags that explains what you should do. But this gives students a better idea of, okay, I have a survey meter in this facility, and not just clicking on it once and the idea disappears. We can also model like check marks so that if a student does complete an item, we can put a check mark instead of a little dash to better indicate that you've completed an object. We can also have a pancake probe, which is just a radiation detector, and their M card. So if students need an M card access, we can put this M card there, and they can essentially scan that to obtain an M card access. Scenario 2 follows a little more of an extended process outside of scenario 1. So we want to make sure that they fully comprehend the procedure. So a lot of these tags will be completely hidden, and students will need to click on them in order to proceed forward. And the tags don't necessarily need to be clicked in order to proceed forward. They can just click the tag and a score will be produced. It is possible that they can miss that tag the second time around. The first time around, we enable it so that they can't miss it, and they have to click on it in order to move on. But the second time around, they can miss it, and their score will be assessed based on if they've completed an item or not. We also want to make sure that they understand certain regulations. So according to the radiation signage here, we want to make sure that they understand why do we have this radiation signage to begin with. And we want them to be able to be familiar with outside resources, such as like the Nuclear Regulatory Commission and the regulations that they have. So our main design strategies for this is we have question tags and hidden tags for the user to find and scored on 8 questions and the number of items they've completed on the checklist. And then lastly, scenario 3, we want them to be able to think through situational events. So for example, if the gas alarms outside the facility go off, what do you do? Or if you get a higher reading on your survey meter, what do you do? And so to do this, we want to do decision branching. So you can do different scenarios and it can branch off into certain ways, and you can be assessed based off of that, as well as human interactions. Who do you call or who do you interact with to proceed accordingly? So the challenges with this is that keeping completion time in mind. We don't want students to spend forever on this, but we want to be able to convey our objectives so that they understand what's going on. Which scenes are important to include. There are certain scenes that are necessary to include and certain scenes that might not necessarily be necessary, but we want them to experience the whole scenario as if they were actually there. Branching and global positioning can be a little bit tricky. This is an example of branching from a scene, and when you have a lot of different tags, it can be critical to keep them in an exact order. And global positioning, certain tags need to be in front of other tags in order to accomplish the objective. So, which tag is best to use in certain situations? Some tags can accomplish the same thing. So, which tag do you want to use? And ensuring the user understands the expectations can be a little tricky to navigate as well. So to conclude here, XR is great for preparing students, and it does save time by letting them take their time. It provides a better understanding of the regulations as to the how and the why we do things. They can be used to model situation events very well. So in case something happens, the student can be like, okay, this is what we can do. And then it ensures better success in person. So this will just overall better prepare students for approaching the source when they actually use it, or outside of the university setting when they use other sources of similar magnitude. So thank you all for listening, and I'd be happy to take any questions at this time. And I've also included my email in case you have any follow-up questions. All right. Well, for the sake of time, I'll pass on the mic to someone else. But thanks so much for listening, all, and appreciate your time. Oh, wait, it looks like we got a question. Is there a web-based alternative in case students don't have Google or don't have goggles? Yes, there is a web-based version of this. So the beauty about this is you can either do this through a link in the web. So we can just provide students with the link and then they can go and access the experience, or they can use this through VR goggles. Our research group is designing a VR game where you can use an Oculus Quest, and we can upload this and do this through goggles. But if they do not have goggles, this can simply just be accessed through the web here. Like, for example, this is literally a link that allows the user, I just had this pulled up on my screen, but you can literally just go and click this whenever. So you can click to get started, and then this gives the user a chance to navigate through the tags and say like, oh, this is the key logbook, and you can click on this and fill and sign the information. And this is all just through a web link. So no worries. Thank you for your question. And again, thank you all for your time. Appreciate it.
Hi everyone. Thank you for staying around. Yeah. Can everyone see my screen? Okay, that's great. So I will go ahead to share the contents then. So my name is Hongrui Yu, and I'm a second-year PhD student in the Department of Civil and Environmental Engineering, working on construction robots with Professor Vineet Kamat and Professor Karim Manasa. Today, I will show you the changes that XR Innovations has brought to the construction engineering and management education. To begin with, visual simulation has been the cornerstone of effective communication of construction processes and operations. 3D visualization, in particular, offer the high bandwidth communication of ideas across the project team, allowing engineers to rehearse the ideas virtually before performing them in the field. Our group Live has been conducting work in this research for more than 2 decades, and our work has led to several fundamental breakthroughs and software tools that have been used in a wide variety of construction processes. In recent years, we have also extended our work and explored the use of AR in the very unstructured construction environment. AR provides a spatial context and background for the engineering and construction process, and it much reduces the effort needed in creating the 3D objects such as in VR. The topic we have explored including user tracking, AR registration, complex visualization, and AR occlusion. Efforts were made to develop both the software system, SMART, and the hardware framework, ARMOR. SMART is short for Scalable and Modular AR Template. This is where we implemented all the research methods and algorithms from this previous research. And the good thing is we keep the developer feature to allow a growing number of tools, and this computing module is therefore reusable and sustainable. On the other hand, as for the hardware framework ARMOR, so this is short for AR Mobile Operation Platform. It is the second generation mobile computing application, which compromises of high accuracy and also lightweight devices that can be used for tracking user interaction, display, and computation in graphics. Together, they much improve the accessibility of AR in construction, and this has also led to several very interesting applications. For example, the one here, we infused the post-earthquake building damage detection with the geo-referenced AR, so the building damage information can be sent in the XR display to the decision maker before we send anyone to a very potentially dangerous building. This way, the firefighters' safety can be guaranteed. On the other hand, we have attached great importance to the real-time application. For example, we have developed a mobile application that will send the underground utility location to the evacuator operators' XR displays before they are sent into the field. And this kind of visual image also guided the whole evacuator operation. Therefore, accidents are prevented and also the utility strikes are avoided. To continue the passion of XR in the future construction managers and engineers, we have also worked on how to better introduce the XR and construction in the CE 435 Building Information Modeling class. This course aims to provide an important foundation in BIM and its major uses, particularly those that affect constructors and facility managers. We introduced several technologies that from our research to the CE class to combine with BIM. So the technologies we introduced include visual immersive simulation and geo-referenced AR that one used for detect the building damage after an earthquake, or real-time visualization of underground utilities. Together, they create a collaborative classroom that will promote active learning. One of the application we also want to introduce to you guys here is called the AR Magic Book. So it is an XR system that let a user to interact with a remote construction job site in various ways and through various interfaces. tangible interfaces are used to connect with the actual field equipment, so bidirectional information exchange can be achieved. Also, the operations can be visualized in geo-referenced AR, where the actual job site is used as the AR background, and we use surface top AR, where a tablet can be used to achieve specific interactions. So as for this tabletop or surface top AR paradigm, it offers much better interaction opportunities compared to the traditional paper-based communication, which is very inconvenient and difficult to handle. Just imagine you have 100 papers and you need to take one out to find one specific drawing, or the computer-based communication where you could lose the interactive collaboration by pointing to one very small point on the screen. And the good thing about it is like we can interactively visualize things in VR with a group huddled around the table. So it is much more interactive. And a full scale of the visual simulation can also be seen on the tabletop AR, and it's not limited to static images in Beam. The user can choose to observe the animation at different speed or jump to any time along the timeline as you want to. On the other hand, to register the images from XR onto tangible interfaces, different markers have been used in the past research. We have used the fiducial, like your tag, or the natural image or videos to better adapt to the different environment we want to use in. Our group has also done some work to develop better markers for construction site. Together, these ideas can be applied to visualize Beam in XR, where specific markers can be part of the paper drawing. By using XR display or headset, the Beam graphics come to life on the top of the paper drawing, dramatically improving the understanding and ability to communicate ideas with the team. With the financial support from XR initiative, which we highly appreciate, we also test this system in the CE435 class. A pre- and post survey was done to gauge the students' experience and to understand the potential perceived benefits. The messages students were sending us is that they find XR is very helpful to help them understand Beam better, and they have also identified several potential uses for Beam in their future field work. So above are the progress on XR innovations in construction engineering and education. Thank XR Initiative for having me, and thank Professor Kamat for the nomination to share the contents. Please feel free to ask if you would have any questions. Thanks. All right, I will stay around in the chat in case anyone has any questions. For the time issues, I will just stop sharing everything so everyone can go to the next session. Thank you for being here today.